In this quick guide video, we're going to learn how to use the pH probe. For more information, go to jb.works and enter the TMT code at the search prompt shown on the screen below. Or you can scan the QR code shown on the right. A pH probe lets you measure how acidic or how alkaline a solution is. So for example, we've got three glasses here. The first one's water, or the middle one is water. This is lemon juice, and this is bleach. So bleach is a very strong alkaline, and it has a pH value of 12 or 13. Water tends to be about pH 7, so it's neutral. It's neither acidic or alkaline. And then lemon juice is acidic, so it has a pH of about 2 or 3. So what this sensor lets you do is, for a liquid, measure the amount of acidity or alkalinity in that liquid. Before we get started, let's have a look at the sensor. So basically we have a cable that goes from the JackBord USI around to the probe, and in here is a glass vessel, and it's protected by this reservoir which has a pH solution in it, a buffer solution which is pH 7, and that protects the sensor, which is this bit on the end. Now, if you look at the picture on the top right-hand side of the screen, you can see the wee ball, which is a glass vessel at the end of the sensor. And this has an electrode in it, and these are what detect the pH of the solution that the sensor is sitting in. So it's really important that, first of all, you don't touch the globe, and that you're very gentle with it. So don't use it to stir like a spoon, and don't bump it or jar it. When you're putting the probe into the solution, you need to fully cover the probe's end here. So the solution should go up to about this level on the probe. And what this will do is the probe basically measures the pH of the solution, converts it into a voltage. This board here processes that and then presents it to the JackBord, which can then show it to you in a program or on a gauge, as you'll see later on. And when you're done with the sensor, you always put the protective cover back on, because that keeps the probe moist and keeps it clean and immersed in the buffer solution. First, you're going to need a pH probe with the USI on it. You're going to need a charged JackBord, 3 jumper wires, female to female, a nut, a bolt, both M4, and a spanner of some sort. And along the top here we've got some bleach, which is granola basically, some water, and a glass of lemon juice. Right, to put it together, so I'm just going to move these out of the way so I don't knock them over. So the first thing we'll do is we'll bolt the sensor onto the JackBord near port B, because we're going to use port B for the connections. So we'll do that. And of course the JackBord's turned off while we're doing all of this. So now that I've got that tightened in there, the next thing we'll do is connect the ground wire. So that goes from the green pin on the sensor to the green ground pin on port B of the JackBord. Then we'll do the 5 volts. So the sensor needs 5 volts, which is why the pin here is red, which means 5 volts. And then that goes into the red 5 volt pin on port B. And then lastly, we need to get the analog voltage out of the sensor and into the JackBord. So we're going to connect a jumper wire from the white pin on the sensor to port pin B1 on the JackBord. So basically we've got 5 volts going from the 5 volt pin on the sensor into the 5 volt pin on port B. We've got ground going from the ground pin on the sensor to the ground pin on port B. And finally, the pH out, or voltage output, of the sensor goes into port pin B1. Use these pictures to check your connections and make sure that yours agree with these. Don't worry if you haven't got the same colored jumpers. The main thing is that the jumpers go to the right place. In these ones, pay particular attention to the red 5 volt jumper, the ground, and the white pH jumper. And on the right hand side you can see where they connect on the JackBord. Before we move on to the first program, if you find that when you're using the program the readings that you're getting don't match what you think they should be, you may well need to calibrate your sensor or calibrate the pH probe. The instructions for doing this, you can find them at jb.works and use the TMT code shown at the search prompt, or just scan the QR code on the bottom right hand side of the screen. To get the code for this first program, you can go to jb.works and enter the TMT code shown on the screen at the search prompt. This program is going to be a pH meter, so it's going to display a gauge that will show you the readings of pH coming from the sensor. To get the code, go to jb.works and enter the TMT code here, and it will take you to the program, and then just select all of the code and copy it, and then come over to the program page and select a program that you don't care about, you can lose, and paste the code in there, and then save it. Right, this is our program, so I think what we'll do is we'll just run it. So I'll click on the rocket. So it's going to display the gauge on the right hand side here, and because I've got the cover on with the neutral pH with the buffer solution there, the reading is 7. So I'll take that off. So the first thing we'll do is we will put it into the bleach, and that is quite alkaline, so it should give a high reading. So there you go, about 12, which is fantastic. Out of there, and then we go into some just water, which should bring it back to about 7. Sometimes it takes a wee while because it has to soak in. There we go. So, and also I'm just cleaning the bleach off here. And then we'll put it into the lemon juice, and that should give a pH, an acidic reading of about 2 or 3. So you can see it slowly coming down. So that is the pH probe working. So basically we're recording over here acidic, in the center neutral, it's gradually coming back up again. And then on the other side we've got a strong alkaline solution, which is the bleach. And then if I just clean it, notice how I'm cleaning it between taking samples. If I put the probe back into the buffer, it should go back to about 7, and it does. Next, we'll take a look at the code. As you'll remember from earlier on, the sensor itself is connected to port pin B1. So the first thing we do is we create a variable called calibration value, and we give it a value of 20.64. You should be fine with this, so when you put the probe into its buffer solution at pH 7, it should give a reading of 7. If it doesn't, then you might need to calibrate the sensor, and I mentioned that earlier in the video. The next thing is the processed voltage. So this is the voltage that the JackBord produces as a result of looking at the sensor. And then this is the final pH value. This is the one that we want. So we go to the program start. The first thing we do is just print a wee message. We set up port pin B1 to be an analog voltage line. And what that means is that the JackBord will just measure the voltage on port pin B1 and produce that and pass that along. This line here is telling the JackBord to respond to very small changes in the input from the sensor, because sometimes the changes in pH can be quite subtle and they take quite a while, and we don't want to miss them. Then we're going to display the title, and we're going to add the quit button, which is that guy there. The next thing we do is go into the program loop. So the first thing we're doing is we're scaling the raw voltage from the sensor, and we're basically doubling it. So that's what this line does. It basically multiply statement takes the value of B1, multiplies it by 2, and stores it in the probe voltage variable. Next, we want to calculate the value of pH. So first of all, we multiply it by the voltage, and we multiply that by minus 5.7 and store that in the pH variable. And then we need to add on the calibration value. So again, we go add pH, and we're going to add the calibration value to it and store the result in the pH variable. And then we want to round it, because if you don't round it, you get it to about 5 decimal points of accuracy, which is kind of annoying. And then here we print the value. So if I go to the print tab, you can see that it's been printing the values. And then next, what we have is the put gauge command, and that's what's responsible for displaying the gauge. And we're telling it to put it at X25, Y75. We want to use the pH value as the value for the gauge. We want the gauge to be 300 pixels wide, and the name will be pH. The minimum value that we show on the gauge, which is on the left-hand side, will be 0. And the maximum value we show on the gauge, which is 14, and that's on the right-hand side. The next line, this line is displaying the current value of pH underneath the gauge. And it's also displayed above the gauge as well, above the center line in the center of the gauge. And then finally, we have a 1 second delay. So we're basically running this every second. So this loop is getting new readings from the pH sensor and updating the gauge. This is program number 2, and it's a variation on the first program. For this program, what it does is it indicates on the screen whether it thinks the solution is acidic or whether it's alkaline. The code for it is at jb.works, and just use the TMT code shown on the screen. Right, this is program number 2, so we'll run it. So the program's running. It's reading neutral, well, it says acid, but it's pH 7. So if I put it into the alkaline, there we are, the program registers that the solution is alkaline. And if I just clean the sensor again, and then I put it into the lemon juice, which of course is acid, it tells you that it's acid. So that's the program working, and basically in terms of the code, all we've done is added this section here. And what this does is the any statement says if the pH goes below 7, then we're going to display the acid message. And if it's not below 7, then it must be above 7, in which case it will display the alkaline message. So you can try things like adding a variation to this so that when it's at pH 7 or in that middle range, it will say that the pH or that the reading is neutral. Or you could try changing the color of the gauge. For more information, visit jb.works.